Hello, my name is Barbara Lang. I'm part of the IEEE's Technology for Sustainable Climate Matrix organization, and I'm here today to walk you through a prototype of the IEEE Technology Assessment Tool. This is a proof of concept that was designed to explore how technology pathways can support a sustainable climate future. The early version offers a limited but illustrative scope featuring 5 countries, and we're going to show some demonstrations of that. The tool applies a forward-looking lens, imagining climate-aligned outcomes at 2050 based on currently published nationally determined contributions, or NDCs, and using backcasting to identify the technologies, enabling conditions, and policy environments required to reach them. The tool organizes technologies into clusters based on their functional role in the climate energy system, providing a structure for comparing options and understanding interdependencies. These assessments are informed by IEEE experts and grounded in high-quality sources, including insights from the IEEE Power and Energy Society's technology roadmap. Users can deepen their understanding through the tool's interactive features, including dynamic radar visualizations and country-specific scopes that reveal how technological priorities differ across regions. In the top corner, there's an embedded AI assistant that is available throughout the experience to encourage users to ask questions about the technologies, metrics, or pathways to support exploration and informed decision-making. As a proof of concept, this platform does not prescribe answers. How users interact with the tool will directly influence its future versions, better supporting planners, policymakers, and experts working towards a sustainable global future. So let's take a tour of the IEEE Technology Assessment Tool. So first, we've designed the tool based on those nationally disclosed contributions of 5 countries and 27 technologies across 8 specific metrics. The 5 countries are Brazil, China, Germany, Nigeria, and the USA. The 27 technologies are according to data taken from the IEEE PES roadmap. So they are organized based on clusters or collections, these 5 collections out of the PES roadmap. All of these technologies are now arrayed across a radar, and the radar gives a representation so that you can do a little more analysis by the visual approach. So we're going to do 3 different scenarios. So let's say you want to understand the comparison between 2 countries as it relates to the use of biomass in future energy sources. So we can go over here to the technology tab and we can click on biomass. And you can see that automatically the radar will focus on biomass energy as a general technology. It is looking, by default, it's looking at the radar across all 5 countries on an average. So if we want to take a look at any specific country, we can do that. So biomass is here. This is the generic for all 5 countries. And you can, by the way, clicking on that tab will also give you an overview of the technology card for each of these various technologies. And now if I scroll through each country, you can see that it moves based on the specific situation in that country. So here in Brazil, we know that biomass energy is a transformative technology, whereas in China, it moves to a more modest approach, and Germany is actually also a high technology. So this allows you to, at a very high level, take a look at different technologies and compare them across the various countries. Now let's say that you wanted to know what technologies are most impacted by the country's NDCs. And for those who are not familiar, the NDCs are a requirement for any country who has signed the Paris Agreement, which is looking for net zero by 2050. And those NDCs are the targets that each of the countries are working towards and declaring together. So one way we can take a look at that, I'll go back to all countries. So this is the generic view, average across all of the countries. And I can go over here and group them. One way I can group them is by the NDC impact fit. So what this is saying is that you can see that it's in a spiral approach, and it's showing the technologies that are most relevant or impactful to the country's NDCs at the high level of on average across all those 5 countries. But now let's say we want to, again, look at it from each country's point of view. We can easily now take a look at what Brazil's most important technology happens to be: biomass energy, followed by wind, solar, hydropower, and green hydrogen. For Germany, you can see the shift is different. The highest technology that's related to their NDC is fusion reactors. And let's take a look at Nigeria. Similarly, same idea. So the approach here is that by rearranging the attributes of the radar, you can get a visualization across all of these countries with one easy go. The other aspects over here, the distance is also an interesting dynamic. So this is the distance that the bubble is to the center of the ring. And right now it is set for the NDC impact. So what its impact is for the country or the region. And we could also change it to TRL. So now you see the 9 levels of technology readiness all arrayed here. And this again is the average across all the countries of where the technologies are and how ready they are. And as you can see, for across these 5 countries, most technologies are near the center and either fully operational or very close to being. But now let's look at it from country to country, and you'll see the dynamics will change. You can see here in Brazil, for example, biomass energy is quite dominant as a ready-to-go technology, whereas fusion reactors is not so ready. Similarly, we can look at the different countries and to see the dynamics and how it varies. In Germany, for example, a lot of technology is very close to being ready. And the size of the bubble also, in this case, indicates the importance it is to the NDC directly. So here we're comparing NDC and TRLs, or technology readiness levels. The last example that I want to share with you is the various attributes. So over here, as I mentioned, there are different attributes. So the size of the bubble can be defined based on any of those 8 metrics, as will be the bar, which is this item here. So it can give you a visual of in comparison to other things. And so you can fool around with this a little bit to get the visualization that means something to you. If you're interested in anything in more detail, you can simply click on that item and you will be presented with the technology card. The technology card gives a definition of the various attributes. So there are 8 metrics that we are measuring, including technology readiness, some financial metrics, skills, availability, social acceptance, policy, as well as that NDC fit, and a brief description of the technology, and also some links to relevant information across the IEEE. Finally, I want to point out the AI assistant that I mentioned earlier. Here's an example of a question. If I want to ask it, these are some suggested questions. So let's go ahead and use one of those, which says, is hydropower better than solar or wind power? I can click on that and it will go through based on the content that's in the tool and provide a real-time answer that you can review and make clicks on and learn more about. So that is the highlight of the tool. We encourage you to use it, test it out, tell us what you think. We are interested in expanding the tool to include a few more countries, as well as doing some market research. So any feedback that you want to provide us, we are very interested in having it. So thank you very much for listening and enjoy the tool.